In this video we will go over the cumulative distribution function. It's known as CDF for short. Let x be a discrete random variable, then its cumulative distribution function, the CDF of x, is defined for any real number x by fx of x equal to the probability that x is less than or equal to x, which can be written in terms of the PMF of x as the sum over all a less than or equal to x of P of a. So we are using a subscript x to denote the CDF function, but if the context is clear, we simply write f of x and skip the subscript. Flip 3 fair coins. Let x be the number of heads, and what we're going to do is sketch the CDF of x. So here is flip 3 fair coins. X is the number of heads, and then the PMF of x is given by this table right here. So refer to that example and see if we can come up with the sketch of the CDF function. So here, first of all, when x is between negative infinity and 0, strictly less than 0, in that case we know that for any of these values the probability, the PMF of x is 0. The probability that x is 0 because none of them are valid values of x. Remember, the values of x are 0, 1, 2, or 3. So what that implies then is that the value of the CDF function evaluated at any such x, which is the same as the summation a less than or equal to x of PMF of a, because P of a is 0 for any such a, we are going to get 0 here. So that tells me that the value of f of x is 0 all the way up to 0. Now, what is f of 0? Well, f of 0 is the same as the summation a less than or equal to 0 of P of a, which will be the same as summation a strictly less than 0 of P of a plus P of 0. But P of a for a strictly less than 0 is 0, so the summation is actually 0, so all I get is P of 0. And P of 0 we know is exactly 1/8. So f of 0 is 1/8. Now, when x is now, let me make some space here. Now think about when x is between 0 and 1. So x is less than or greater than or equal to 0 is strictly less than 1. In that case, what can I say about f of x? Well, it should be the same as f of 0. right, which is 1/8. So basically that means the value of the CDF function is 1/8 all the way up to is 1/8 between 0 and 1. Now at 1, what happens? Well, what is f of 1? Well, f of 1 is the summation a less than or equal to 1 of the probability that x is a, which is the same as the probability, which is the same as the summation a less than 1 p of a plus p of 1, which is basically f, capital F of 0 plus p of 1, which is 1/8 plus p of 1 is the probability of getting 1/2, which we know is 3/8, which is going to give me a half. And so that means that the CDF function will be half from 1 up to 2, because we know between 1 and 2 it stays the same. And in a similar way, you can show that the value of the CDF function at 2 would be 7/8, and then it stays at 7/8 until we get to 3, and at 3 the value is 1, and then it stays 1 for any value of x greater than 3. Okay, so notice that the jump at I is exactly the probability that x is I. Here I is 0, 1, 2, or 3. A couple of facts that you want to realize is, what's the limit as x goes to infinity? What's the limit of f of x? As x goes to infinity, the limit of f of x should be 1. As x goes to negative infinity, the limit of f of x should be 0, and f of x should be between 0 and 1, of course, because f of x is a probability value which should be between 0 and 1. And notice that f is right continuous, that is the limit of f of x as x goes to a from the right is the same as f of a. So in the picture you can see that if I look at the limit of f at any real number from the right is the same as the value of the function of the CDF at that real number. Okay, so I want to make 2 more remarks here. The probability that x is strictly greater than a, less than or equal to b, is the same as the probability that x is less than or equal to b minus the probability that x is less than or equal to a, which can be expressed in terms of the CDF function f of b minus f of a. What's the probability that x is strictly less than b? Well, I can say it's the limit as n goes to infinity of the probability that x is less than or equal to b minus 1 over n, which is the same as the limit as n goes to infinity of the CDF function f evaluated at b minus 1 over n. My last remark on the CDF function is, any probability question about the random variable x can be answered in terms of the CDF function. So once again, make sure you read the notes and understand the concept of the CDF function. In the next video, we will introduce expectation.